doing crude oil now. How do I do this now? Let's do it this way. Right, crude oil is a mixture of hydrocarbons. It comes out of the ground as a mixture, and then what happens, you heat it up. It then goes up this column called the fractionating. Let me write it properly. Fractionating column. It's hotter at the bottom, it's cooler at the top, and then depending on the boiling point, it'll evaporate, and when it gets to the right temperature, it'll condense and then it's collected. So at the bottom, you end up with bitumen. You then end up with fuel oil. It's actually called fuel oil. Then you have diesel, dye, and then cell. Then you have kerosene. Then you have gasoline. We call it petrol. And then you have, there's a few names for it. Liquid, petroleum gas, liquid petroleum gas, or LPG. Sometimes they call it refinery gas or refinery gases. Right, so really what you've got to learn is 1, 2, 3, 4, 5, 6 products that come out of there. What else do I need to show you? Right, okay, bitumen is for making roads. Fuel oil is a fuel for heating and ships. Diesel is fuel. Don't forget the word fuel for trucks or lorries. This is fuel for planes. This is fuel. Gasoline is fuel for cars. These are the best terms to use. And this is camping gas or camping stoves, or it's for camping stoves in those little cylinders. So you've got to know all this. There's a story that goes with it, but we can do that some other time. Right, so what you've got is 1, 2, 3, 4, 5, 6. Okay, they're all there. So now, if you look carefully here, right, this is more. So you've got 10% by mass, but there's only a 2% demand. Gasoline for cars, 12% by mass, but there's loads of demand. Right, why is the market demand greater for gasoline, petrol, than fuel oil, than ships? Right. Right, so what you have here is gasoline is used as fuel for cars and okay, that's why. And there's more cars, many more cars than ships. So that's fine. That'll do. Right, cracking. Cracking. So what happens is, okay, how do we do this? Right, cracking is where you break down large let's not be lazy, hydrocarbon molecules into short chained molecules. There you go. Right. Right, what are the conditions? Let's get this right. The catalyst used is silica, which is sand, or aluminium oxide. Alumina. Right, the temperature is 600 degrees. Right. So we're breaking down C20H42. So there's 20 carbons and 42 hydrogens. We're breaking it down into 16 carbons. We've got 20 carbons, so we need another 4 carbons because they have to balance out. This here is the middle. Right, so you've got 4 carbons and we've used 34 hydrogens and we need another 8 hydrogens. Now they're balanced out, so look. Let's look at it with the mass. So you've got 20 carbons, you've got 16 plus 4 is 20, you've got 42 hydrogens, 34 plus 8 is 42. Right, give the name of the catalyst and what temperature. So we said the 2 catalysts that we can use, no, you can call it silica. Really, the chemical name is silicon dioxide or alumina. Aluminium oxide. You can use any one of those two. And the temperature 600, I remember it as, but you can say anything between 6 to 700 degrees. Anything within that range. Right, okay. Ethene can be produced, so remember, look, this comes up a lot. It's good to know this off by heart. So there's 2 carbons. It's an ethene, it's an alkene, so you've got a double bond. Each carbon has 4 bonds, so you've got 1, 2. So you've got 1, 2 bonds there. So I can do, right, we can write it like this for now, yeah? So you've got hydrogen there, hydrogen there, hydrogen there, hydrogen there. So you've got C2H4. It can be produced by cracking long chain hydrocarbons from crude oil, and then it can be used to make ethanol. Ethanol can also be made by fermentation of sugars. What are the 2 advantages of making ethanol from ethene? Right. It makes a purer product. That's how I remember it. And it's a faster process. Right. It also makes, it's a continuous process. So it's not like a batch process where you put it into a vat or a container and then leave it. Right, what happens is any any raw materials that are left over, they recycle. So it recycles raw materials. So you end up with 100%. It's called 100% atom economy. Okay. What the reason? Sometimes fermentation is used. So right, okay. Fermentation is where you use. So look, fermentation. You need glucose. You need yeast. You need a body temperature of about, I don't know, 30, 37 degrees. So normally they say between 30 and 40 degrees Celsius. You end up with ethanol, and you end up with carbon dioxide as waste. That is not good for the atmosphere. It's a greenhouse gas. Right. It's a renewable resource. Renewable resource. It takes place at lower temperatures, so there's not much energy. Temperatures, it's like almost at body temperature. So if you have a suitable climate, countries can use that. Or if you do not have access to crude oil. Right, okay. So crude oil, you crack it, no, you heat it, fractional distillation becomes airplane fuel oil, then you crack it, becomes ethane, then you react it with chloride, chloroethane, and then you make it into a polymer, polychloroethane. Right, process 1 is called fractional distillation. That's in that big tower that I drew earlier. Alright. Describe the differences between crude oil and kerosene. Average size, covalent, and viscosity. Right. The word viscous, it means how thick a liquid is. They want you to answer those three. Right. Crude oil has larger molecules. Crude oil has a higher viscosity. Viscosity, right. Viscosity, what else would there be? Right, okay. Covalent, right, okay, it's got much more bonds. Crude oil has many more covalent bonds because they're larger molecules. It has it's crude oil is darker in color. What else can we say? It's harder to ignite, so it's less flammable. It's less flammable. So it's any one of these. Kerosene has a fixed or sharp boiling point, or whilst crude oil has a range, because it's a mixture. It has a range of boiling points. Okay, that's it. That'll do. Right. So now watch this. What they're doing is they're doing it in reverse now. So they're saying you get a hydrocarbon here, and when you crack it, it becomes this and this. So now we need to balance the number of carbon atoms and hydrogen atoms. So look, we've got 5 carbons here, and we've got 2 carbons here, but we've got 2 lots of. So look, what they're saying is you've got this molecule here, carbon and 4 hydrogens, but you've got 2 of them. So really we've got 2 4 carbons. Yeah, equals 4 carbons. So altogether we've got 9 carbons and we've got 12 hydrogens here. You've got 12 hydrogens and you've got 8 hydrogens. So you've got 20. So you've got 20 hydrogens. That's cool. Okay, so X is 9, Y is 20. Give the name of compound C5. So remember we said monkeys eat peanut butter, meth, eth, pro, bute. Those are 1 carbon atom, 2 carbon atoms, 3 carbon atoms, 4 carbon atoms. Then after that it's quite straightforward. You've got 5 carbon atoms and it'll be like pentagon. It'll be pent. 6 hex, hexane, pentane, pentene, hexene. So these are the prefixes. We've got 5 carbons, so it will be pentane. We need to draw the displayed formula of C2H4. This is really common. It's good to know that off the top of your head. So I've got 2 carbons. It's an ene, so I'm going to do a double bond. And each carbon atom has got 4 bonds. So look, you've got 1 carbon bond, 2 carbon bonds, 3 and 4. So stick a H there, H there. So this carbon has also got 4. 1, 2, 3, and 4. You can count these as double. Which ones? Where are we? There, these carbon ones. Right, there you go. So we've put H there and a H there. So we've done the displayed formula. Right. So what we're trying to do is draw the displayed formula for the repeat unit of polychloroethene. Poly just means what? Many, doesn't it? So they want the repeat unit. So all it is carbon, carbon. So you've got carbon, carbon. You've got 1 hydrogen, 1 hydrogen. Watch this, I'm going to do it this way. And then I'll change it. So you've got 1 hydrogen there. And you've got 1 chlorine there from this one here. Right, what happens is this breaks up. And you end up with, no. There you go. Alright, polychloroethene is formed by something called addition polymerization. There's 2 types of polymerization that we are interested in at the moment. Addition polymerization and condensation polymerization. There you go. You've got 1, 2. It's good to know these. Addition means you take loads of little molecules like this and you only have 1 product. Yeah. Right. With this one, you take your molecules here and you end up with the main product and a little one that you've lost here. That's the condensation part, where you lose a little bit. Right. So how does condensation differ from addition? So in condensation, polymerization. In condensation polymerization, you lose a small molecule. Right, okay. What does the word biodegrade mean? When something is biodegradable or biodegrades or can biodegrade, it can be broken down, right, by microorganisms or bacteria. Use the word bacteria or microbes. This is what it is though. It's important to know that. Commit that to memory. What feature of addition polymerization makes it difficult for them to biodegrade? They are inert. Inert just means unreactive. But use this word. Nope. Nope. That's the one. Use the word inert. Right, let's keep going. Crude oil is a mixture of substances which describes the main substance in crude oil. They are hydrocarbons. Crude oil is made up of hydrocarbons. Alright. This is a technique used to separate crude oil. You heat it. The ones with the lower boiling point evaporate, go up here, go down here, and are collected in here. Then you swap out with another test tube. And then as the temperature goes up, the next set of hydrocarbons start boiling and evaporating. And that there is a thermometer. It is used to measure the temperature. That's a P, by the way. P. Okay. Right. We need to put these in order. So first of all, for the crude oil, that makes sense. Let's pour the crude oil. The second one they've given is fit a thermometer. Right. Then you heat it. Nope. You connect a delivery tube. Right. Okay, we're going to connect. That makes sense. It's no good heating it because you lose it. So R, collect each fraction, heat, and then collect. That order. Served. There you go. Served. Right, let's keep moving now. Oh, there it is. Should have copied this. So what did we say bitumen was for? So look, crude oil vapor, because what have they done first? They've heated the crude oil to turn it into vapor so it can travel up here. We said this is hot and this is cool. Alright. Bitumen is for roads. Fuel oil is fuel for ships or heating oil. Diesel or diesel is for fuel. Don't use just trucks. Fuel for trucks. These are the best ways to do it. You can argue, oh, so there's some diesel cars, but you just get yourself into trouble. Kerosene is fuel. Don't forget the word fuel for what? Planes. Gasoline, or we call it petrol. Petrol. It is fuel for quad bikes. But refinery gases is it's used for camping gas. Right. Which has the lowest boiling point? It's refinery gases because they evaporate first and go to the top. So it's refinery gas. Most viscous. Viscous, we said it's just another word for thick. What is its thickness? It will be bitumen because it's the biggest hydrocarbon in terms of the length of its chain or the mass. Right? So you're going to use cracking to turn octadecane into octane. So you've got 18 carbon atoms and 38 hydrogens. We crack that and we produce C8H18. Now we need to balance these. So we add C10 and we've got 38, we've used 18, so it'll be H20. Now get this. You 8 there, 10 there. Right, okay. Right, okay. Why is it important to crack long chain hydrocarbons or hydrocarbon fractions? Right, best way to answer this, there is an oversupply, as in there's too many, of long chain hydrocarbons, and a higher demand for, okay, we'll carry this on, for short chain hydrocarbons, so e.g. gasoline for cars, and ethene for making plastics, you say, for manufacturing or making plastics. Right, done. Right, now, ouch. So let me just go over that again. The microphone was away. There's an oversupply of long chain hydrocarbons, and there's a greater demand, there's a higher demand for short chain hydrocarbons. And then we put in there, not that color. For example, gasoline for cars, fuel for cars, ethene for making plastics. So really what we should do is put gasoline for fuel for cars. Okay, no, that's fine. Right here, that mark should be an arrow to show those are the reactants, those are the products. The incomplete combustion of octane produces a poisonous gas that reduces the capacity of blood to carry oxygen. When you combust something, you're going to get carbon dioxide or carbon monoxide. They're both not very good if you breathe them in, but this is especially dangerous. This is called carbon monoxide. Monoxide. This is carbon di, meaning two, oxide. Right, the reason this is probably worse is because it stops or right chemical. Oh, okay. Whoa. You want a chemical equation? I'm trying to give an explanation. Right. Read the question. Octane. Oct is 8, so it's CH 18 plus oxygen. I'm going to balance it in a second. Gives carbon monoxide to water. We've got 18 of these. So we've got 9 oxygens, 10 oxygens. Or 9, 10. How many carbons? Oh, no, I'm lying to you. Let's get rid of this. I am not a balancing man. But let's try to balance it. So we've got 8 of these. Got 8 of those. So we've got 8 plus 9. Got 17. How much would that be? That would be 7.5. You can get away with 7.5. What you could do also is carbon monoxide, 8 of those, 9 of those. Right, I can't count. I cannot count. It's been one of those days. 8.5. That's 17 oxygens. 8 carbons, 17 oxygens, 8 carbons, 8 plus 9 oxygens, that's 17, that's fine, them two match up, and you've got 18 hydrogens, 9 times 2 is 18, so they all match up. That's fact. Right, okay, that's about half an hour. There is lots. Okay, if you see this sort of a repetition, so what we'll do is we'll leave that for the next video, inshallah. Right, okay, that's cool.